Good morning to all of you. So, in the last class, we have learned how we can represent the paired spins. Like in helium, you have two electrons, which we say that their spins are paired. So, what does that mean? When we say spins are paired, that essentially means that the angular momentum, spin angular momentum, is zero. Spin angular momentum has to be zero. So as I told you, whenever we have to show angular momentum, we show it on the cone like this, okay, with the vector pointing anywhere on the cone. The z component gets fixed, right? But if you're looking at this diagram, and when we so what you see, there should not be any component of angular momentum left. It should totally cancel out and it should be zero. The resultant must be zero. But in this picture it doesn't seem to happen. ऐसा होता हुआ दिखता नहीं है कि यहाँ पे ये जीरो होता हुआ नहीं दिख रहा है. ओवरऑल एक नेट एंगुलर मोमेंटम रहेगा इस पिक्चर में. ठीक है, दो वेक्टर का जब आप सम करेंगे, two vectors, one pointing like this and another one highly like this, so you see there will be net resultant which will come out to be something like somewhere here. It is not exactly cancelling out. So this is not a correct representation of paired spin. But if I represent one of them on the cone, like going like this, and the other electron, the spin angular momentum is like this, then they are exactly cancelling out, right? Net resultant is zero. So this is the correct way of showing the paired spin paired system, okay, as it happens in helium atom, right? So zero resultant should be there of the angular momentum, spin angular momentum, right? The vectors, two vectors that lie at an indeterminate position on the cones, that I have told you earlier. But as soon as you place in a spin pair, as soon as place, the first vector can be placed anywhere on the cone, अपर कोण से ऊपर वाले में आप कहीं पे भी एक इस वेक्टर को रखिए, लेकिन जब वो रखते हैं तो दूसरा वाला फिर फिक्स हो जाता है, बिकॉज इट हैज टू बी कैंसल्ड आउट. सो इफ one lies on its cone, the other points in exactly the opposite direction to make the resultant zero. So one is pointing in this direction and this one is pointing here. So that's how it is cancelling out totally. When you were showing like this, you were only cancelling out the z component when you write like this. Okay, so that correct picture, when this was only the z component that was cancelling out. The xy component was not. You were just not considering it at all, right? So now if you view it in totality, the spin angular momentum vector is, this is how it is oriented, and we have to account for the total cancellation of the spin angular momentum, right? Not just the z component. Okay, so this is how we do it. Then we also talked about Pauli's principle, the general one, which applies to uh, all the particle system, which so the general form of the statement, it goes like this. This is the general form, very generalized statement of Pauli's principle. So remember, this is Pauli's exclusion principle, which you talk in terms of electrons. When you are with respect to electrons, is a special case of Pauli's principle. एक पॉली प्रिंसिपल है और एक पॉली एक्सक्लूजन प्रिंसिपल है। पॉली प्रिंसिपल से पॉली एक्सक्लूजन प्रिंसिपल आया है। पॉली प्रिंसिपल में दोनों चीजें, बहुत सारी चीजें हैं कही गई हैं, और उसका स्टेटमेंट थोड़ा सा ऐसा खतरनाक सा है, देख के डर लगता है, लेकिन हाँ, डरने की जरूरत नहीं है। इफ यू कैन start decoding it, you will be able to, yeah, if you understand each of the terms, you can easily decode it. Okay, so the total exchange of wave functions, whenever there is a, the total wave function must change sign. जब भी आप labels को exchange करेंगे, any two identical fermions, and electron is also a fermion, and so this is what we have been applying. और इसी का बहुत simplified version आता है कि दो इलेक्ट्रॉन जब भी एक ऑर्बिटल में होंगे तो उनका स्पिन सेम नहीं होगा, they must have different opposite spins, right? So one is having ms, the z component, as ms plus half, then other one having ms, the z component, as minus half h cross. So that was the part that we were interested in, and in the last class I had discussed it at length. So the total wave function क्या था? Orbital part of the wave function. So radial wave function, angular wave function, ये combine करके orbital wave function हुआ. And then you add to it the spin wave function. That gives you total wave function, including the spin. The orbital part, the spin part, that gives you total wave function. So that total wave function must change sign when we interchange the label 1 with 2, 2 with 1, electron number 1 and 2 are exchanged their respective places. That way you can think of. Okay, so then there must be, so that's what we say, it must be function of position as well as spin of the particles, the total wave function. And when you change the labels, that you change the positions, then the sign of the wave function must change. And that we saw that so the Pauli's exclusion principle has it originates from theory of relativity, and it is a very fundamental thing, exists in for all particles, which applies to all fundamental particles: electron, proton, neutron, photons. So any bosons, fermions, all follow this Pauli's principle, right? And then, so this is what we want to happen, that 2 1 1 2, when you exchange the places, this should happen, the sign will change, plus to minus. So something like this should happen with a minus sign. And that we found that how can we achieve this, so I also told you how to write this. So psi is a representation of the angular wave, the orbital part of the wave function, total orbital wave function. And in a similar way we assign alpha and beta as the sign of the wave functions for spin states. So a plus half spin state, minus half spin state, so alpha and beta respectively. So that's what we can imagine, four different combinations that we call it, both in alpha, both in beta, alpha beta, beta alpha, like this. So spin state combinations, then we realize that it is not correct to express, we are not sure which electron is having plus half, which electron is having minus half spin. So in that context, it is not correct to assign it like this, that one is completely alpha, one is another beta. So we express this thing as a linear combination of both the spin states. That is the safest thing to do. So when we are uncertain, we can't specify whether electron number 1 is having up spin or 2 is having down spin. Then we write in this way. We can combine the two spin wave functions, one here and then like this. So two combinations can be worked out, like psi 1 plus psi 2. So just like we have psi 1 plus psi 2, psi 1 minus psi 2. So that way you are writing here. And then we total wave function we are summarizing here. We can imagine 4 wave functions, total wave functions. And we at first we realize that when we change the labels 1 and 2, the product remains unchanged. When we look at this one, alpha 2 change label over here, beta 1 beta 2 alpha 1, so the product remains unchanged. So there is no change in sign in that case, and we discard these two things we are first discarding. And then we okay, and I also told you to how to write this spin orbital, the wave function, total wave function, in a shorthand notation. So in general, if nth electron has spin alpha, then alpha in that n and psi n is a wave function, then this is how we are going to write. Alpha is a superscript, so this is shortens the thing. In short, you can write indicate the wave function, orbital wave function, as well as the spin wave function. So we call it spin orbital notations. So then you can have beta spin, so you give a superscript of beta, and within bracket write the nth numbering of the electron, 1 2 3, like that. So that's we discussed yesterday, and we are moving forward. So we found that when we analyze the third one, it is also there is no change in sign when we replace the labels, because the products, these two, some of the two products is essentially the same. But when we are comparing this, we exchange the labels 1 with 2. Sorry, when we realize that this is one type of product, and we are subtracting beta 2 alpha 1, alpha 2 beta 1 minus, and the second one, when we change the labels, it becomes the reverse. 1 goes here, 2 goes here, 2 goes here, 1 goes here. And then we realize that this is altogether different. So alpha 2 multiplied with beta 1, beta 1 alpha 2. So this multiplication is essentially the same. So if we assign it as A, then we also realize beta 2 alpha 1, beta 2 alpha 1. This product should be essentially the same. Let us assign this B. So this is A minus B, and this becomes, this whole thing is B minus A. Something like this is happening. So then we find that yes, now the sign is changing. If we write it like this, so this negative sign is over here when you are representing, writing it this way. So exchange of labels bring about a change in sign. So that is the, so this is, so out of the 4 equations that we considered, only one is satisfying the Pauli's principle, and that one is the final that we consider. So we say that this wave function is antisymmetric. It changes sign when the labels are changed. Okay. So up to this is fine. And now we uh, move to the next part, where we have to consider the effect of uh, the phenomena penetration and shielding. Shielding you have studied earlier in your earlier school days, as well as in bachelor's degree. So what, and penetration, I don't know whether you are familiar with it or not, but in BSc you should have learned. Let me explain what it is. So now we know that the energy of electron is proportional to two things. There are two terms that determine that is the varying. When you move in the periodic table and visualize one electron in each of the, another influence of each of the nucleus of elements, then you find that Z changes, the nucleus, the proton number of proton changes as you move from one atom to another atom. And so accordingly you will have for the same given value of n, the energy would change, right? It will become more negative. अगर आप एक से दो प्रोटॉन हो गया तो क्या होगा, दो दो का स्क्वायर करेंगे तो 4 हो जाएगा, 3 का स्क्वायर करेंगे 9 हो जाएगा. सो उसी 1s ऑर्बिटल के लिए एनर्जी जो है इट विल बिकम मोर एंड मोर नेगेटिव. Energy will become more and more negative as z increases, right? So you have to realize one thing. As suppose you are moving across the periodic table, आप periodic table में move कर रहे हैं, what do you find? Z increases more rapidly than n. Can you realize this? इस statement का मतलब समझ रहे हैं आप क्या मैं कह रहा हूँ? देखिए, so you should be able to visualize what is said here. जैसे ही आपने सेंटेंस पढ़ा, z increases more rapidly than n, आपके दिमाग में क्या आता है? क्या आप रियलाइज कर रहे हैं क्या मैं क्या कह रहा हूँ? नहीं. So let me, it should strike immediately that let's start moving through the periodic table. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, and so on. So what do you find? Z क्या है? Z is 1 2 3 4 5 6 7 8. How is the n changes? The last, look at the last electron. Where does it enter? 1 1. Last electron in the n value 2 2 2 2. So you have moved from hydrogen to oxygen. Z changes from 1 to 8 while n changes 1 to 2, right? And that's what will so n, the change in n is much slower as you move through the periodic table, but the change in z is much faster, rapid. So that's what this statement says. And so when you calculate, the energy is proportional to what we have just said, minus z square by n square. ये proportionality है. So now you try to evaluate z square by n square. You just see what happens. So now if you try to evaluate z square by n square, here it is 1, it is 4 by 1, it is 9 by 4, 16 by 4, 25 by 4, 36 by, like this. So you realize, so you see, z square increases more rapidly. That's what we say. So z square n square is fast increasing. Z increases fast. So numerator changes very fast. 1 z square by n square is the thing. You can clearly see 1 by 1, 4 by 1, 4, 9, 16, 25, 36, 49, 64. Whereas the denominator changes 1, 1, 4, 4, 4, 4, 4, 4, like this. So that if numerator changes very fast, so what do you expect? The energy will become more negative. Energy will be, the electrons will be drawn closer to the nucleus. It will be very difficult to take out the last electron. That's what it indicates. So you realize this? Are you getting this point? So अगर आपको compare करना है hydrogen, helium and lithium, okay? So as you are moving to lithium, the Z by N value here, for lithium, Z by value, so let's take example of lithium, and what we are trying to say is for lithium, oh, क्या वो stylus, Okay, so for lithium 9/4. So as compared to, so the energy required to take out the last electron, so energy will be something minus 9/4, and for hydrogen it is minus 1 by certain constant. So energy is turning out to be more negative. That means lower energy. It is the electron is having negative energy much closer to the nucleus. So it ऐसा हमें appear होता है, ठीक है. Electrons have been, but so if you calculate based on that, सिर्फ z by n के बेसिस पे अगर आप एनर्जी कैलकुलेट करेंगे तो एनर्जी रिक्वायरमेंट जो होगी, let me just rub it off. So if we compare, so what I said just now, keep in mind. So I said Z increases more rapidly than N. We have seen in case of lithium that it is becoming more, and जितना वो इलेक्ट्रॉन Z by N का वैल्यू बढ़ेगा, बहुत तेजी से बढ़ रहा है. So compare lithium with hydrogen. So as the Z increases, it should become, you will require more energy to remove the electron, because energy बहुत नेगेटिव हो गई है. मतलब it is, you have to give the same amount of equal amount of energy in positive terms. जितना नेगेटिव हुआ है उतना ही आपको एनर्जी इनपुट देना होगा, तब वो निकलेगा ना. So that is what we, when we compare the ionization energy, so energy required to take ionization energy is a measure of energy of that electron जो जीरो से वहाँ इनफाइनाइट डिस्टेंस सेपरेशन से आया और एटम का हिस्सा बना. So compare Z is equal to 1 with Z is equal to 3, hydrogen versus lithium. What you find that instead what we have been expecting कि लिथियम में अगर 3 है प्रोटॉन, तो उसको 3 प्रोटॉन के अट्रैक्शन की वजह से उस इलेक्ट्रॉन पे अगर हम इंडिविजुअली, if we are looking at the electron, outermost electron under the influence of 3 protons, it should be strongly pulled inwards and you will require higher energy to take that out. So ionization energy would have been higher as compared, if we go only by z square by n square comparison. But practically what we find that it is much easier. In contrast, पूरा उल्टा हो जाता है. The ionization energy for energy required to take out that electron in 1s is this one, 1312 kilojoules, whereas for lithium, if you want to take out the last electron in 2s1, then the required energy is much less, 520. तो z by n का तो, so there is something wrong with what we have been thinking. Yes, कुछ एक missing out है जो हमने अभी तक नहीं इक्वेशन में काउंट किया. अदरवाइज एनर्जी का कंसिडरेशन इतना वेरी नहीं करना चाहिए. तो क्या छूट रहा है यहाँ पे? So there are few things that we have to consider. Average radius of 2s is larger than 1s, and the second important point which we have been missing all along is that 2s1 electron is repelled by the inner 1s2 electron. So when 3 electrons are attracting that outermost electron, at the same time from the inner core orbital 1s में जो 2 इलेक्ट्रॉन हैं वो उसको रिपेल भी कर रहे हैं, और इस वजह से 2s1 को, जो 2s में इलेक्ट्रॉन है, that is easily removed. You understand? If the third 2 electrons were not present in 1s orbitals, and simply if you are just hydrogen like orbital treatment you are giving, you find that individually, if I look at that third electron attracted by the single by 3 protons, I would require much higher energy, much higher than hydrogen. But आप z by n कैलकुलेट कर लीजिए, ठीक है ना. लेकिन जैसे ही आप देखते हैं, रियलाइज करते हैं, अरे नहीं, इसमें तो अंदर में जो दो इलेक्ट्रॉन है वन एस शेल में, इन द फर्स्ट शेल यू हैव टू इलेक्ट्रॉन्स, they repel this the outermost electron, so now it will become easier to take away that thing. And this something that we have to understand. This is the point that we need to understand. So visualize this outermost electron in the lithium. This is the electron in isolation. We are considering individually the third electron in the 2s shell, second shell. And suppose, so this feels attraction between these, so there will be strong attraction between the two, three protons pulling the single electron. So it looks like it will be much difficult to take out this electron. ऐसा हाइड्रोजन में एक ही प्रोटॉन था जो खींच रहा था, यहाँ पे तो तीन तीन प्रोटॉन है. लेकिन if you imagine that if suddenly two electrons come in between, what will happen? So initially this electron, in absence of anything in between, this electron was able to see three protons. That is, it was able to feel the force of three protons on it. But when two electrons are coming in between, when these two electrons come in between the three protons and this outermost electron, this electron is not able to see the total three protons at the nucleus. It is because these two electrons, which are oppositely charged, they have negative charges, so they will effectively cancel out some of the effect of electrostatic field, and the net force that this final electron will feel will be much less. Okay, so what we find that this is what we call shielding. The decrease, the inner core, the inner core electrons repel the outer ones, and we say that and because of that, the valence electron that we were considering, it is now able to see only a part of the total nuclear charge. जो मैंने पहले आपको कहा कि in absence of any disturbance, this electron, the valence electron, is able to see the three protons, complete charge at the nucleus. When there are two electrons that come in between, it can see only a part of the total charge. तीन प्रोटॉन की जगह उसको इक्विवेलेंट ऑफ एक प्रोटॉन ही मिलेगा, मतलब ऐसा कुछ अपीयर होगा roughly. Okay, so there is a reduced, so that is, so जो वो इफेक्टिव फोर्स फील करेगा उससे करस्पॉन्डिंग जो आप चार्ज कैलकुलेट करेंगे न्यूक्लियस पे, उसी को हम इफेक्टिव न्यूक्लियर चार्ज कहते हैं. सो दीज टू इलेक्ट्रॉन्स आर एक्टिंग एज अ शील्ड. तीन प्रोटॉन है वो बाहर वाले इलेक्ट्रॉन को खींच रहा है, और बीच में ये दो इलेक्ट्रॉन दे एक्ट एज शील्ड, कि उस फोर्स को रिड्यूस कर देते हैं. ठीक है, एंड दिस इज व्हाट वी मीन बाय shielding or screening. We call it screening. So shielding of the nuclear charge is happening. These two electrons in the inner layer, inner core electron, act as a shield, reduce the force of the nucleus on the outer valence electron. So, or in other words, we say that the valence electron is able to see only a part of the total nuclear charge, and this we call as effective nuclear charge. This is something that we call as effective nuclear charge. जो टोटल चार्ज नहीं देख पा रहा है, तो कितना के इक्विवेलेंट उस पर फोर्स लग रहा है, वो क्या फील कर रहा है. So that is what we know as effective nuclear charge. And this phenomena of the inner core electrons repelling the outer one, and due to this repulsion, the overall attractive force of the nucleus is reduced. This is what we call as shielding. Okay, so this is what I was telling you. So you have outer electron and you have inner electrons, this one. This is the total nuclear charge Z, and this you have to consider that Z, this nucleus is attracting the blue lines. Look at the blue lines. So outermost electron, the nucleus is trying to pull them closer to themselves, attractive force. At the same time, the inner core electrons are repelling, the red lines, the red arrows. See, red arrows, repulsion. So because of this repulsion, inner core electrons are repelling the outer ones, and because of that, overall force, the nuclear, the attractive force is reduced on these electrons. So if you back calculate how much charges effectively will be at the nucleus from the point of view of these electrons, so that is your effective nuclear charge. Okay, so this is what we know as shielding. शील्ड कहते हैं ना किसी चीज से ढाल की तरह बचाना, तलवार से someone is attacking you, you act as a shield, बीच में आ जाते हैं, तो उसी तरह से ये पुल करने की कोशिश कर रहा है बीच में, ये जो लेयर ऑफ इलेक्ट्रॉन्स है, इनर कोर इलेक्ट्रॉन्स दैट एक्ट एज अ दिस inner layer of electrons act as a shield, ये shield की तरह काम कर रहा है. So these are acting as, so if I may take this, this is your shield, as shield, ये shield की तरह काम कर रहा है, ढाल की तरह बीच में आके ये इसको खींच रहा है, इस पे आउटर मोस्ट इलेक्ट्रॉन को. ब्लू लाइन आप देख रहे हैं और रेड लाइन रिपल्शन. So this is the, so inner core repulsion is the, so basic is that it is the inner core repulsion, or you can say the interaction of inner core electrons with the outer electrons, which is giving rise to shielding, or simply say inner core repulsion is the reason for this shielding. Now this little bit of understanding of physics is necessary, what I am going to tell you now. So in electrostatics you have must have studied about this Faraday cage. Faraday cage का होता है, the same concept applies here. So if my test charge is somewhere here, so if my test charge is here, the electron that I am considering is here, and there is a distribution of negative charges that is due to the electrons inside this blue purple circle. So and there's protons here at the nucleus. So and this, so the electrons which are so the force of nucleus that will be on this test charge, and this is the positive here and these are the negative. This distribution of electron that we have seen, so something like this, so electron density is there inside this circle. The positive charge is here at the nucleus, and so if you have to consider the net effect will be, so if the test charge is outside that, so it is like what we say, you have a spherical distribution of charges, positive and negative charges, so net effect will be the same as if the magnitude of the total charge of the electrons with a sphere of radius r, so it will be the, it can be represented by so it will feel the same force as the total charge positive minus the negative charge inside the sphere. Okay, so that Coulombic, so because of, so there is a reduction, so so net effect is that equivalent to a point charge at the center having सो अगर 3 प्रोटॉन है और बाकी जो जितने इलेक्ट्रॉन डेंसिटी है उसको इससे माइनस कर दीजिए, सो दैट विल बी द टोटल इफेक्ट ऑन द टेस्ट चार्ज। सो पूरे डिस्ट्रीब्यूशन को आप समराइज करते हैं, यू विल सम इट अप एंड so we have to average all over the location of the electron. So the overall effect, the full charge of the nucleus is reduced from Ze to Z effective, and that's we call it as effective nuclear charge, Faraday. So the concept of Faraday cage is there. So any test charge, any electron that is outside on the other side of this test charge will not affect this interaction between the nucleus and the test charge. Anything that comes in within this circle, inner circle, that will affect the overall attraction. So this Z effective is commonly referred to as effective nuclear charge. So there is overall reduction in the force with which the nucleus would have attracted this test charge, the electron that you are visualizing, and anything outside the cage is not contributing that to the reduction. The other any other distribution of negative electron densities that will consider it. So in physics, when you solve this kind of problem, you have to you distribute all the distribution of the charges within a sphere. You just subtract the positive charges minus sum all the charges together and consider it to be at the center. तो टोटल जो सम करके चार्ज आता है विद इन द स्फीयर, उसको आप एक सेंटर पे विजुलाइज करते हैं और उसका फिर इंटरेक्शन देखते हैं. सो सिमिलर थिंग इज हैपनिंग हियर. You have a large number of protons at the center and a less number of electrons within this sphere inside purple sphere. So there will be effective charge at the nucleus will be reduced, and that is what we consider the interaction between them. So that reduction in the charge is represented by a factor called shielding constant. So electron experiences a shielded nuclear charge. This is what we have. So the inner layer of electrons, inner core electrons, form a shield for the nucleus, and not allow it to completely the outer electron to see the total charge at the nucleus. It is not able to feel the total force. So the reduction in the charge at the nucleus overall, that the out मतलब बाहर वाले इलेक्ट्रॉन पे जो दिख रहा है उसके हिसाब से जो रिडक्शन इन चार्ज है उसको हम इफेक्टिव न्यूक्लियर चार्ज कह रहे हैं, and that is given by the shielding constant. So it is a blocking. So the electrons within that circle, within that sphere that we are considering, the inner core circle, inner core sphere, is actually blocking that Coulombic attraction, full Coulombic attraction from the nucleus of the nucleus. So this is the net out what we try to express. This is a simplified approach of expressing the overall nuclear attraction in the context of repulsion from the inner core electrons, and we try to view it as a single equivalent charge at the center. Single equivalent charge at the center, we visualize that applying the concept of electrostatics, where when we have distribution of charges, जो distribution of charge है उसको आप पॉजिटिव नेगेटिव सबका मिक्सचर है उसमें आप पूरा सम कीजिए and then visualize that total charge positive sum of the positive and negative to be center at the center, and then work out the actual thing, work out the interaction with the outer electron. So that's how we are considering over here. Now this probability diagram that we discussed in earlier. So there is some so how they are related to the shielding. Let's see. So you see here, very close to the nucleus, 3s, 3p, and 3d. What we have here, probability diagram. This is the radial probability function. So what you see here is that, look at this point, very closer to the nucleus, close to the nucleus. What do you observe? 3s, 3p, 3d. 3s electron has a finite non-zero probability. Non-zero, fine. Look at this point. यहाँ पे देखिए, ये सारा non-zero area है. So it has a finite probability of being found very close to the nucleus. 3p में वैसा नहीं है. And it is you can also see that there are two subnodal maxima closer to the nucleus in case of 3s. ये क्या था? Subnodal maxima. We call it subnodal maxima. दो नोड 0 इलेक्ट्रॉन डेंसिटी के बीच में एक फाइनाइट इलेक्ट्रॉन डेंसिटी वाला पॉइंट. तो इसका मतलब ये है कि this, although 3s electron has a larger most probable radius, it also has two subnodal maxima closer to the nucleus, right? And immediate vicinity, in the immediate vicinity of the nucleus, we can clearly see that it has a finite probability of being found over there. That is, a 3s electron approaches the nucleus much closely as compared to 3p. 3p का उसी पॉइंट पे 3p का 0 है. यहाँ देखिए, this is 0, and so it has less probability. The 3p electron has much less probability of being found in the vicinity very close to the nucleus. So in the area closer to the nucleus, 3s has much higher probability of being found. 3p has it has only one subnodal maxima, so you have two subnodal maxima, one subnodal. तो हम एंड 3D का और भी कम है. इसका तो यहाँ पे भी था, जहाँ पे इसका सब्सटैंशियल इलेक्ट्रॉन डेंसिटी है, इलेक्ट्रॉन प्रोबेबिलिटी है, यहाँ पे ऑलमोस्ट 0 है. सो 3D का प्रोबेबिलिटी और भी कम है, वेरी क्लोज टू द न्यूक्लियस. A 3D have very less probability of being found. A 3p has little more. A 3D orbital, no subnodal maxima in this region. No subnodal maxima. So इसका मतलब क्या हुआ? जब 3s इलेक्ट्रॉन न्यूक्लियस के काफी पास है, तो इट इज एबल टू वो उतना अच्छा शील्ड बनेगा उसके लिए. So the closer, if an electron reaches a nucleus much closely, then it also forms a better shield for the nuclear charge, right? So 3s orbital is able to shield the nuclear charge much better than 3p, and 3p is shields the nuclear charge much better as compared to 3d. So the shielding power is changing. 3s is more efficient in shielding the nuclear charge, 3p is slightly less, 3d is the least. And this is because of when we analyze this probability function, radial probability function, closer to the nucleus, nucleus के बहुत पास आप इसको एनालाइज कीजिए ठीक से, आप देखेंगे कि 3s में दो सबनोडल मैक्सिमा है, मतलब देयर आर टू प्रोबेबिलिटी लूप्स दैट यू कैन सी. और जहाँ पे वो पॉजिटिव प्रोबेबिलिटी है, एकदम नॉट फाइनाइट प्रोबेबिलिटी है, वहाँ पे 3p के उसी स्केल पे देखिए, वहाँ पे ऑलमोस्ट 0 है प्रोबेबिलिटी. सो जितना पास वो पहुंच जाएगा न्यूक्लियस के, उतनी अच्छे से उसको शील्ड कर पाएगा. 3p थोड़ा सा कम है, 3d का और भी कम है, probability of being found very close to the nucleus. And so this is what we have. The shielding ability is different for 3s 3p 3d, or for that matter. So 3s orbital, we have seen that it is 2 subnodal maxima closer to the nucleus. So greater, it has greater, we have, so it is very likely to be found very close to the nucleus, and so it will be able to shield the nuclear charge better, in a better manner. In a similar way, in contrast, 3p electron has one subnodal maximum, we saw that, and probability is less in the vicinity of nucleus, so it will be less effective in shielding. So overall, the order is 3s 3p 3d. 3c is the most efficient in shielding, so we can say that the shielding constant, or the shielding ability to shield the nuclear charge, is greatest for 3s, less for 3p, and least for 3d, right? And in general, for given n, this changes in this manner: ns, np, and d. At the same time, one thing is also important here. The other thing that I'm going to discuss now is penetration. So what we have been looking till now is the inner core orbit. Sorry. Okay. So we have been treating the inner layer of electrons as a shield, and how they are protecting the nuclear charge. Okay. Now look at this. If we say, so these are the probability curves for 1s, 2s, and hmm. So the penetration is something, a phenomena that we attribute to, ये देखिए 1s का ये जो है डायग्राम, प्रोबेबिलिटी कर्व आएगा, ऐसा कुछ आएगा ऊपर जाके, समथिंग लाइक दिस. Sorry, it's so it is going up above the graph, above the pictures that we have here. So something like this, we will have the probability for 1s. So this is the 1s. Then in the second shell you have 2s and 2p. So what we see here, this electron, the 2s electron, has a larger most probable radius. 2p orbital has a lower, less, the most probable radius is less, right? 2s का most probable radius ज़्यादा है, 2p का कम है. लेकिन look at the probability function. It has a 2s orbital has a much higher probability of being found very close to the nucleus, and inside the 1s orbital. 1s orbital के जो आप रेडियस डिफाइन कर रहे हैं, उसके अंदर भी ये 2s इलेक्ट्रॉन पाया जा सकता है. It has a much finite probability being found over here. Okay. Whereas the 2p electron has a much less probability. You can see the curve here, the purple one. So you have second shell electrons, which has a 2s electron has a finite probability of being found inside the 1s radius, within the 1s orbital. So 1s का जो रेडियस डिफाइन किया है, उसके अंदर भी, so ये penetration है. तो when we are, penetration is a property of the outermost electron, how well it is able to penetrate the inner layer of electrons and reach the nucleus closely. मतलब न्यूक्लियस के कितने पास तक वो पहुंच जाता है. 2s इलेक्ट्रॉन न्यूक्लियस के काफी पास तक पहुंच रहा है, यहाँ तक कि 1s ऑर्बिटल का जो रेडियस है, उसके within that nucleus very close, it crosses that layer and reaches the nucleus very closely, while 2p has less ability. So this is what we call penetration. अगर 2s ऑर्बिटल न्यूक्लियस से काफी पास पहुंच रहा है, as shown by this probability diagram, finite probability being found very close to the nucleus. Okay, that means it will also feel a greater attraction from the nucleus. 2p is not able to approach the nucleus that much closely, so it will feel less attraction from the nucleus. तो क्या होगा? So we say that 2s has a more penetration of the inner layer of electrons, inner core electrons. It can penetrate the layer of inner electrons and reach the nucleus, approach the nucleus closely. And when it approaches the nucleus closely, it also feels the force, attractive force, strongly. And because of the attraction between the nucleus and this 2s electron, the energy will decrease. And that's why 2s will have less energy as compared to 2p. 2p के कंपैरिजन में 2s का एनर्जी कम होगा, although the radius of 2s is larger. Most probable radius of 2s is larger, yet the energy of 2s is lower because of the presence of subnodal maxima in the probability curve. ठीक है, this is the penetration. So remember, we have to, when we think about shielding, that is a property of inner core electrons. When we are talking about penetration, so that is a property we think in terms of the outermost electron has. एक है कि वो अंदर के जो इलेक्ट्रॉन्स हैं वो एक लेयर की तरह न्यूक्लियस के पास कितने अच्छे से न्यूक्लियर चार्ज को शील्ड कर सकते हैं, उसके अराउंड शील्ड बनाते हैं, एक घेरा बनाते हैं उसके। और दूसरा है कि ये जो बाहर वाला इलेक्ट्रॉन है वो कितनी आसानी से इस घेरे को पेनिट्रेट करके चीरते हुए न्यूक्लियस के पास पहुंच जाता है, दैट इज पेनिट्रेशन। ठीक है, तो जो जो बाहर वाला और इलेक्ट्रॉन जितनी आसानी से पेनिट्रेट करके अंदर न्यूक्लियस के पास पहुंच जा रहा है, वेरी क्लोज टू द न्यूक्लियस, वो उतना स्ट्रॉन्ग अट्रैक्शन फील करेगा न्यूक्लियस का और उसकी एनर्जी कम होती जाएगी। फॉर द सेम रीजन यू कैन ऑल्सो सी when you compare 3s 3p 3d, 3s will approach the nucleus much closely, so it is surpass the layer of second shell. It will also pass the layer of one first shell electrons and then reach the nucleus so closely, इतनी पास तक आ जाएगा न्यूक्लियस के। तो अगर ये न्यूक्लियस के इतनी पास पहुंच रहा है तो इसकी एनर्जी 3s की जो एनर्जी है वो कम हो जाएगी, because of it will feel a stronger attraction from the nucleus. And so again the penetration, so this is what we, so this property of outermost electron to be found in the inner to be found inside this thing, so this is called penetration. Okay, the presence of an electron, an outer electron inside the shells of other electrons is called penetration. So outer electron inside the shell of other electrons, this is the inner electrons, is called penetration, right? So a 2p electron does not have penetrate so much effectively, जो अभी आपको मैंने बताया, आप देख सकते हैं प्रोबेबिलिटी डायग्राम में इसका बहुत कम है वैल्यू यहाँ पे प्रोबेबिलिटी का। So because its wave function goes to 0 at the nucleus, whereas 2s electron has maximum amplitude at the nucleus, so we can expect that penetration of 2s will be better. So this is what we call penetration. 3s, similarly 3s 3p 3d, when you are visualizing that, 3s has largest radius, most probable radius, but it is also having finite, very finite probability of being found close to the nucleus, 2 loops, and so it will feel stronger attraction, its energy will be less, and that gives rise to this change in ordering of energy levels. So this is happening because of shielding and penetration. So shielding and penetration is the reason why in a multi-electronic system you have this 3s 3p and 3d have different energies because of this the greater penetration that we just saw कि 3s 3p 3d में एनर्जी का जो डिफरेंस आया, क्यों आया? क्योंकि एक 3s इलेक्ट्रॉन is able to penetrate better, penetrate the layer of inner shell electrons, first shell second shell सबको penetrate करके चीरते हुए, मतलब it is cutting across through that layer of first second shell electron, then the first shell electron, and reaching the nucleus. So we have seen in the probability diagram that happens, and so we can clearly say that it will feel stronger attraction from the nucleus. If we compare the same thing with 3p, we find that it was not having the ये green वाला जो है इसका उतना रीच नहीं है न्यूक्लियस के पास, थोड़ा सा बहुत कम है प्रोबेबिलिटी, 3d का और भी कम है. तो जो फर्स्ट और सेकंड, सो यू कैन इमेजिन दैट यू हैव फर्स्ट the 1s electron will be 1s will be somewhere here within the first shell. There is a finite probability of finding out the third shell 3s electron, and this is penetration, right? So it is more able to penetrate better, and that's why we have less energy for 3s, more energy for 3p and 3ds. Okay, got it? मतलब 3s का मोस्ट प्रोबेबल रेडियस ज़्यादा है लेकिन एनर्जी कम है. क्यों कम है इसको समझिए, ठीक है? So this is what we have. The staggering of energy levels 3s 3p 3d, this happens 4s 4p 4d like this, 2s and 2p. This is multi-electronic system. In the multi-electronic system, because of electron, so basically it is electron-electron interaction that changes the thing. When you have more than one electron, it is the inner core repulsion, the shielding, and then which gives rise to shielding and penetration. And we have, because of that, the energies of the 3s 3p 3d changes. Similarly 4s 4p 4d will change, and so on. So energy of the subshells within a given shell will change because of this reason. Thank you.